Okay, welcome back. This is Mr. Hassan's Maths channel. I've now got up to question number 15 in the specimen paper for the 2025 IGCSE 0580 non-calculator paper 2. Now this question here is about transformations, which is something that's been in the syllabus for a long time, and we're given these two triangles. One of them is shaded and it's called T, and the other one is unshaded called A. It says describe fully the single transformation that maps triangle T onto triangle A. So it's one single transformation that we have to mention that maps these two triangles one onto the other. Now what we can see very clearly here is there's some sort of rotation that has taken place. So if we were to have a look at this and rotate this where it is, we can see we're going to get a shape that looks like that shape, right? Exactly the same as A. So there's definitely a rotation that's taken place, but that rotation has taken place about a particular center. There's a point at which it's taken place that we have to find. So we can see it's a rotation, and we can see that it's clockwise, and we can see that it's 90 degrees. So those three things we can determine quite easily just by looking at that. So we can say points that we can make is that it's a rotation. Okay, and we can say that it's clockwise, and we can say that it's 90 degrees. So those three things won't give us the full marks. We need one more thing to mention, and that is the center of rotation. Now that's probably the single most kind of confusing thing for most students about this topic of transformations, how to find the center of rotation. Okay, especially when it's not obvious. Of course, the center of rotation here, it can't be the origin. Okay, if you rotated that clockwise about the origin, it's going to go down here somewhere. So the center of rotation, as we can see, must be somewhere in this region over here. So we can take a few guesses if you want to, but if you try some different places, you'll notice that they won't work. And how you can try them, one good way is to use some tracing paper. So here's a bit of tracing paper that I have. Well, I've kind of made it into tracing paper. Alright, so you put the tracing paper over the object, and then you rotate it about the point that you think is the center. Now I kind of deduce that the center is going to be over here. Right? I can see that because if I rotate that 90 degrees clockwise, it's going to end up over there, and this 2 squares down is going to end up over there, and 2 squares down and 3 across, going to be 2 across and 3 up. You can kind of deduce it, but if you want to be sure, you can take your tracing paper, trace the shape on the tracing paper, keep an eye out for where you're starting, like when this handle here is on the top, you can make a little mark on the tracing paper. Alright, and when this handle now is going to be in this point here, or that mark you make over there is going to be in this position, you've gone through 90 degrees, and you can just rotate the shape, and you can see it fits exactly over its outlines. It's not that accurate because of the way I've done the tracing paper, but you'll see that you basically fit over the original over the outline of where it's supposed to go. So therefore that is the center of rotation. So that's one way of finding the center of rotation. So I can say the center of rotation is going to be the point 4, 3. Okay, so we can put center 4, 3. Okay, so it's rotation clockwise of 90 degrees, and the center is the point 4, 3. Now there's also another way that you can work out the center of rotation, and that's by finding the perpendicular bisector or bisectors of the lines that join two separate points. So for example, I can see this is the right angle, okay, on this triangle, and this is the right angle on that triangle. If I join them together, okay, and I draw a line that is halfway between them, passes through the point halfway between them and is at right angles to this line. So that would be a line that goes like perpendicular to this line. It'd be diagonally this way. Okay, so you can see you don't even have to use any type of special type of constructions. So you can see here that it's going to be a line that looks something like this. It's going to go diagonally across like this. You can see it goes to that point, so that's confirming it in, well, half confirming it. And then we can also draw a line joining two other points on the graph halfway through them. I'm not going to join these two together because it will give me the same line. So let me join these two together. Let me join these together. Okay, now what's halfway between these two lines? Okay, let's have a look. Exactly halfway between them. It's like you're going one across and 1, 2, 3, 4, 5 up. So it's going to be like a half across and a 2.5. So it's going to be, it's kind of like where this thing was there. That's halfway exactly between the beginning and the end. And if you draw a line that's perpendicular to this line, okay, then now how can we work out what's perpendicular? We can use a protractor if you want to, or you can say the gradient of this line is rise over run, so it's 5 over 1. So the so if you have a gradient of a line which is 5 over 1, the perpendicular line will be negative 1 over 5. So if you want to draw a line that's perpendicular to this, you've got to go 1 down, okay, and then 5 across to the right. So 1 down and 5 across. So 1 down, 1, 2, 3, 4, 5. Basically, it's going to be a line that goes like this. It's going to join these two together. You can work that out. You could maybe this particular question, because we don't have a big enough grid, we can use even a protractor, or we can just, you know, we can see what 90 degrees is quite easily, and you can see that it goes through that point. So when the perpendicular bisectors of points of, you know, joining of the line joining corresponding points, if you choose 2 points that make different lines, then you'll see that the perpendicular bisectors will always intersect at the center of rotation. Okay, now if you don't really have to resort to this this last method. You only would really use that method if you couldn't, you know, have any idea of where it is. But the tracing paper is normally a good way of you know, figuring it out. So you take your tracing paper, you draw the outline of the shape on the paper, you put the pencil at the center of rotation, and you rotate, and you see that you get to where you're supposed to get to after 90 degrees clockwise, and there's the answer. Okay, so I hope that was clear. That's the end of this question. Pretty simple one. So that's the, question number 15 done. Other questions from this paper you can find in the playlist. That will be a link will be posted over here. Other questions from the topic of transformations from this new syllabus, which won't really differ from the old syllabus, but anyway, I'll put the newer questions in this playlist, and the older questions you'll find in a playlist over here. And you can subscribe to the channel by clicking on this link. Thank you for watching, and see you soon.